Okay. All right, everybody. Good morning, good afternoon, good evening, wherever you are joining us from. Welcome to the 1 week Agentic AI Week 2025, organized by Machine Learning in partnership with other communities like Python, Anambra, Computer Vision Africa, New Lens AI, Python and Darlens AI. So, talking about AI, we have been hearing a lot of things about AI. What is AI? What is artificial intelligence? So, currently in the world, we have been experiencing and seeing a lot of new inventions around the AI space. So, that is what led about this session on AI agents. So, today, being the first session, we are going to explore what AI agent is, its applications, its capabilities, and what do we mean by AI agent. A lot of people understand what AI agents are, but when we talk of AI agent, does it actually mean giving to LLMs? I see AI agents as something much more better, or let me say, much more with more capabilities than just giving tools to LLM. Okay, so on this particular first session, we are going to explore, understand what is AI agents, what can AI agents do, and why do we need AI agents now? Once again, my name is Victor Jacob Asuquo. Welcome to day one of the AI Agents Week. Feel free to tell us where you are currently joining us from in the chat section, either in the group or in the Google's group or live in this call. Ask your question. I'll be going through the chat section to see if there is any question. And also feel free to connect with anybody here. Okay. So after now, I'll be dropping links to the groups in the comment section because at the end of this section, at the end of this session, we are going to have assignments and projects. Oh, I have to speak slowly. I'll try my best. So at the end of this session, we are going to give out assignments and projects to people so that we actually don't want to make you have a light understanding of what is artificial intelligence or what is agentic AI, but we want to give you a deep understanding of AI agents. So to proceed here, I'm going to walk you through I'm going to walk you through what we have here in our slide. So these are the speakers that is going to be joining us to host this session. We have Anyekit Ekere from Turing. How many of you know Turing? Turing was one of the companies or one of the best organizations to prove that AI can actually mimic the activities of human beings, and it was the first test it was the first AI test to actually beat human. We also have Felix Ibiema Amaka from Python Anambra, who is also going to take us on the introduction or take us tomorrow on the AI Agents Week. We also have Irene Ufia, a senior development engineer, who is going to take us on deploying AI agents. We also have Mboitanke James, who is an AI engineer at Meta. And lastly, we also have Daniel Samuel, the CEO of Lens AI, and also the co-founder of Computer Vision Africa. So as you can see, we are bringing in experts to give you practical hands-on on what you are going to build. So you are going to cover a lot of topics from beginner to being able to prototype and then build your application. So even if we are not able to cover everything today in those practical, but from our next session tomorrow to the last session, if you combine all these experiences, it's going to give you hands-on practical experience, going to give you hands-on knowledge. So even if I know some of the questions are going to be around deploying AI agents. How do we deploy AI agents? We have a DevOps engineer here to guide you through deployment. So for today, we are going to talk about introduction to AI agents. Introduction to AI agents. What are AI agents? So yes, before we continue, I'll just share one more thing. So I'm going to share in any of the groups, I'm going to share our repository. I'm going to share our repository where we currently have all where we are going to have all the resources, the lab sessions, the code sessions, and the assignments you are going to do. So just go to github.com/machine learning-io. Then you see the AI agents week, you see the AI agents week. So for each of the days, there's actually going to be um there's actually going to be a repository for each of the days. There's actually going to be a repository for each of the days. So you can just go there, explore the session materials, explore the assignments, and try to, you know, contribute and go through the resources. And at the end of the day, there will be a capstone project for you to do. There will be a capstone project for you to do. So please, there's a lot in store for everybody. There's a lot in store for everybody. There'll be a capstone and where you are going to get your certification. So also, you just have to make a pull request. Once you make a pull request, provide the link. So you're actually going to go through your code to see what you are doing, to see what if you really understand this concept. And our programs, they are they are 100% free, and they are very interactive. So in some cases whereby we have the we have the session, let me say 1 week is not enough, we can continue to the second week and continue hosting the program. So talking about AI agents, what are AI agents? Okay, we have heard of AI agents. So what is AI agent? Is there anybody that wants to share what he or she understands by what AI agents are, or why we are suddenly talking about AI agents? Or simply put, if I say something like AI agents, what do I mean? Or what am I trying to? Is there anybody that wants to share that has an idea of what AI agents is? Yes, feel free to unmute yourself and speak. Is there anybody that wants to share what AI agents is all about?
Okay. My name is Nibia Tinyan, as it's rightly shown on the screen. I would simply say that an AI agent means an autonomous system or a kind of a program that can perceive its environment, carry out reasoning or planning, and then get onto action to be able to achieve a particular goal.
That's really good. That's really impressive. So we have talked about we have talked about we have talked about at least for we have given a basic understanding or a deep overview of what AI agents are. So we are going to explore on that idea. So I'll just change my screen sharing, and then I'll present something because I actually want us to solve the web. Okay, so let me just go here and all right. So AI agents. Okay. So yes, what are AI agents? AI agents are software systems that use artificial intelligence to autonomously perform tasks and make decisions on behalf of users or other systems. Okay, they can perceive their environments, reason, plan, and act to achieve goals, learning and adapting over time. So the case example I usually use to explain AI agents is look at AI agents as a junior employee going to a company, going to an organization, right? look at AI agent as an employee going to an organization, is currently trying to learn to adapt to new environment, then taking decisions. And if at any time a task is assigned to that employee, is going to think, right? Set up a task pipeline before going ahead implement um to implement this this task, right? Let's say build a particular feature in a software. And after building, it's also going to go ahead and it's going to, let me say, get feedback and continue the process again. Hey, this program is not working correctly, it's not working effectively, or we need another layer, we need another layer. So talking about AI agents is not just, AI agents are very, very powerful. AI agents are very, very powerful. So I'll just this I'm going to follow this diagram we have here. So um so throughout everything we are going to use here, I'm going to share the resources. Might need to use a lot of resources to be able to, to be able to meet up with, because I don't just want you to have like, I need you to have a deep understanding. Also look at, we are also going to look at AI agents from so I have the code here. We are also going to explore a simple customer agent. We are also going to look at that, and then different frameworks and how we can integrate it. All right. So, and also another resource we are going to use is the Hugging Face Hugging Face AI Agents course. I think there is this has a deep illustration. This, we are also going to use the material here to deeply explain what AI agents are, introduction to agents, yes, what are AI agents, and then we are also going to look at the chain of thoughts. So I'm giving you like a rundown of what we are going to do today. And also, we have a program here. We are going to build a customer research agent. So talking about AI agents, there are certain things you need to know about AI agents. Number one, reasoning. Okay, AI agent has the ability to reason. So given a particular task, let me say I want to buy coffee, right? I want to buy coffee. Okay, I want to buy coffee. And I tell you, okay, can you get coffee for me? What are you going to do? First, you are going to look at your environment. So that is where your environment comes in. And in this context, your environment can be any external data source. It can be the system that we are going to relate to, right? Then you are now going to reason what is really required of me. Okay, what is really required of me? Then we are going to set up the next task. We are going to set up the next task. Okay, I have to go get coffee, prepare it, and bring it back. And so basically, that is the workflow of an AI agent. So I'll just go back to the slide we had here. So conceptual and theoretical definitions of what we mean by AI agent. We have perception and interaction. AI agents perceive thoughts via sensors and influence them through actuators and or percept or output. So this is starting from the basic building blocks of artificial intelligence. We have autonomous decision making. They operate independently using internal goals and knowledge guide to act them to guide actions. Okay, learning capabilities. Agents can adapt based on experience, refining their strategies over time. So agents, that is why we need to add memory to when building AI agents. Um, memory is a way to Memory is a way to give understanding and contextual meaning to our agents. So it learns from. That is why if we're actually starting with a chatbot for the first time, when you go back there, when you go back to starting with a particular chatbot, you see that it can understand basic information like your details and every other thing. So memory is very, very crucial for AI agents and agents reasoning. Okay, so we continue. We have interdisciplinary roots. They draw from AI, they draw from AI, cognitive science, decision theory, and system theory. So talking about the basic on that, you know that actually we need a base model, we need a base LLM to which acts like a brain to an AI agent. The best LLM is going to act like the base where it thinks for the AI agent. For example, you can decide to build your agent on top of any LLM like Gemini, OpenAI, Microsoft AI, or let me say open source models on Hugging Face, even DeepSeek. So agent needs basic understanding of not just it needs large understanding, which can then be tailored and given tools to be able to execute and do a lot of things. So theoretical fundamentals of AI agents, interdisciplinary origins and core concept. Okay. So we are going to look at artificial intelligence, core algorithms and architectures underpinning agents reasoning and behavior. So when we look at this, right, I'll just go here directly on Hugging Face, and then I'm going to show you. Yes. So we have we have we okay, let me just go here. So I'm just going to break down. So before fulfilling the order, an agent engages in reasoning and planning. Remember that our buying coffee example, right? Before fulfilling the order, Alfred engages, let's say Alfred is the name of our AI agent, engages in reasoning planning, figuring out the steps and tools he needs to. He needs to go to the kitchen, he needs to use the coffee machine, he needs to brew the coffee and bring the coffee back. Okay. So now here you know that there are certain things the agent need to know and understand. And in this case, once he has the plan, he must act, he must execute the plan. So execution, this is where the agent is actually going to say, okay, I need to do this at this time, I need to do this at this time. And then you just go into the brain. So now I want to explain the core three concepts or the core things that you need to be able to successfully build an AI agent. So we need first thing first, the brain. So this is where all the thinking happens, right? You are able to, let's say we have a traveling assistant, and you ask it something like, how is the weather condition in a particular region? I like, hi, the weather condition in this region is let me say in Nigeria is sunny, in US is a little bit hot or is a little bit warm. So they need these capabilities, this understanding to be able, which act as the brain, to be able to list out tasks, to be able to reason and then execute a particular task, right? So the brain, which is the AI model, this is where all the thinking happens. The AI model handles reasoning and planning. it decides which action to take based on the situation. The body, that is capabilities and tools. After the brain, you need capabilities and tools. What does capabilities and tools mean? It means giving AI the access or the toolkits or everything it needs to be able to execute a task. So when we look at tools, basically we are looking at functions we are given to this AI agent. We are looking at functions we are giving to this agent, right? So let's say, for example, we are building a research assistant or a research agent, right? And we are building a research agent, right? And you can give it a tool like search the web. Okay, so you know that this particular tool is actually going to enable the AI system or enable the AI agent to actually go and search the web. And at what point do we need to search the web? Remember that before now, LLMs or AI agents, they were hallucinating, right? Because they didn't have context grounding. Context grounding is very, very important. And today, a lot of AI features now have things like search. So if you are prompting your LLM for a particular, you are prompting your LLM for a particular thing, you can now do what? You can click on search. So it's going to go to the internet, get grounding, search, and then summarize the output to you. But look at any functionality or any specific thing as a tool. And these tools are codes, they are functions, they are softwares, right? So we can look at tools as, let's say, I'm building an agent for an agricultural firm, for example. I can give it tools like what are the tools I can give it? Can give it tools like um, get um, get treatment for a particular disease. I can give it to check the lifespan of a particular crop, and I can give it to like, let me say, check the check the duration for a particular treatment. So now here's the thing: we can also have, there are different structures and flow for building an agent. You can have agents. You can also have a multi-agent. That is an agent inside an agent which is linked to another agent, and then interact the same way. Then they interact the same way. So in this case, we need to give it capabilities, right? So we can see here that the body, that is capabilities and tools. This part represents everything the agent is equipped to do. The scope of possibilities actions depend on what the agent has been equipped to do. For example, because humans lack wings, they can't perform the fly action, but they can execute actions like walk, run. So here's the thing: sometimes we might like our AI agents to have, like, let me say, this very cool feature, and then let's say it can check if a flight is available, the best route to use to go to a particular route, for example. So here is the thing: if you did not build this capability, if you did not build this tool for your AI agents, don't be surprised your AI agents won't have the won't have the capability to do so. It won't have the capacity to do so, because why? It doesn't just have the tool, it doesn't just have the what it takes to be able to, let me say, walk through it. And some of the examples or some of the ways we can include this in our code includes number includes we can use, okay, some of the tools we can add is, let's say, a simple processor. You can call the function to process LLM response, if LLM decision, and then you can structure our tool and continue. So what type of task can AI agents do? An AI agent can perform tasks we implement via tools to complete actions. Remember that an AI agent needs to have something in mind to do. So it can now perform tasks. For example, in a particular conversation, let's say your AI agent has the ability to your AI agent needs the ability to extract IDs and then return status if that payment was successful, if it was declined, and where the payment was made to. So that example of a task, right? And we have to do what? We have to give, we have to build that tool for it to perform that action. For example, if I write an AI agent to act as my personal assistant like Siri on my computer, and I ask it to send an email to my manager asking to delay meeting, I can give it some code to send emails. This will be a new tool agent that use whatever it needs to send an email. So um this is just an example and a use case whereby AI agents cannot just generate content, but it has the capability to send that email. And thank God for MCPs now. You can integrate it directly into your, let me say, into your Slack, into your Discord, and it will be able to do the things like, let me say, the things you want to do, or the things it's supposed to do. Send message to manager, can we postpone today's day? So it's all about providing the right context, providing the right thing, and then making it do its magic. So another use case example is AI agents powered by LLMs can make non-playable characters more dynamic and unpredictable. So you can also use AI agents in this case. So let's discuss now. Let's go deeply into what AI or LLMs are, right? Large language models, which is the brain. You have been hearing of transformers, right? We have been hearing of transformer. I just want to pause here and then open the floor for the participants to talk and be able to interact. So who can share what LLMs are, or transformers, or anything you understand about large language models? Yes, yes, please feel free to unmute yourself and speak.
Yeah, good afternoon, everyone.
Yes, good
So,
afternoon.
when we talk about large language models, we are talking about um, a kind of a tool, an AI, a program. Should I call it a program? Should I call it an agent? So, what it does is it takes a kind of it can take a, a group. It can take text. It can also take audio or any form of data. What it does is to match the data with a specific language and come up with something in an intelligent conversation, either translation or a kind of a conversation response. It all depends on what the output will look like. If the output is designed for translation, it gives a translation. If the output is designed for conversation, it gives us conversation. So it's a kind of, it's what is used to design bots. You know bots now, and that a kind of, how do I call it, agentic bots and other response um, platforms. So that is what I actually understand by large language models.
Thank you very much, Mr. Um, Anedi, for that warm contribution. And I'm really, really super excited. So before I proceed, I don't want to make it boring. Is there anybody else that wants to contribute, or that wants to add to um, what we have said so far, or any idea or any contribution talking about transformers, LLMs, and large language models, how they work, or anything you have in mind? Do you have any contribution from anyone else? Is there anyone else that wants to continue with that? Okay, so I'll just continue. So what are large language models, right? You know that large language models, they are transformer architectures which have been trained on vast amount of data. I mean vast amount of data. I mean the entire internet. That's why you see billions and billions and billions and billions of parameters. Okay, so we have different examples of LLMs. I'll just go. Okay, this is most of the um, models and their providers. We have heard of DeepSeek R1 from DeepSeek, GPT-4, which has multimodal capabilities from OpenAI, Llama 3 from Meta, and then one of our speakers is currently working on training Meta, Llama for Meta. We have small agents from Hugging Face. We have Gemma from Google. We have Mistral from Mistral. So it's good for you, is fundamental for you to understand the three types of transformers, to understand transformer architecture. For example, we have encoders, we have decoders, and we also have sec-to-sec encoders, right? So an encoder based transformer takes text for other output data and a dense representation or embedding of that text. Okay, for example of model that is based on this architecture is bets from Google. We also have text classification, semantic search, and other things. We also have a decoder based transformer focused on generating new tokens to complete a sequence, one token at a time. We also have sequence to sequence. I mean, depending on any of the LLM you are using, right? Depending on any LLM you are using, it's really, really important to have it as the brain so that you can get in touch, so that you can understand. Because the thing is, how open source LLM work is different from how production grade LLM works. Okay, so you need to understand this. You need to understand these differences. Okay, it will help you to structure your LLM well. So let's go back to our slide. We don't really have much slide left. I think we have like just one more slide. And mostly what we are going to do here is going to be also by coding. We also do by coding as well to be able to where is that slide? Where is the slide? Okay, yeah. So we have implemented, we have explained about decision theory, talking about having agents the ability to, let me say, reason and execute tasks. Next, we have autonomy in AI agents. So now, autonomy, self-governance, and independent decision making. You know, I've actually been thinking of something. What can we do, or how can we, like, imagine we are building a reinforcement learning for an AI agent built on top of an LLM. What do you think about that? That is so great, right? So it means that we are building AI agent that is self-aware. We are building AI agent that is self-aware. So self-governance and independent decision-making, self-directed action. Agents initiate behaviors without external commands based on internal logic, right? Goal formulation. You can generate, revise, and pursue objective independently. So basically, that is how AI agents work, right? Just like I said, look at AI agents as a junior employee or a junior staff in a company. It's going to, it will be able to, do a lot of things. It's going to do things like execute, go back to. So there's something a lot of people missed out when building AI agents, which include number one, observability. observability is very, very important. So what this actually means is that if we have an LLM, right? If we have an LLM, okay, or let's say if we have an agent, right? An agent, an agent is an agent is not, let me just say generally AI system. Yeah, I actually define AI system as an iterative software engineering process. Yes, an iterative software engineering process. So it has task one. Let me even show you what that means. Let me show you an example of that. So it has task one, it has task two, it has task three, it has task four. So what happens is going to go through the first step, right? Okay. Does this process meet what I have to do? Does this process meet what I have to do? Right? Do I have to redo it again? Then if not, it will go back to an initial stage and then continue doing it. So that is just the beauty of AI agent. I mean, then imagine AI agent having the capability to, so basically, goal formulation, they can generate, revise, and pursue objective independently. We also have independence reasoning. AI agents AI agents exhibit logical inference to act rationally in complex scenarios. Minimal human intervention operates effectively without needing continuous oversight. Okay, so minimal human intervention. Actually, I was working on a project, right? And the project was initially I just wanted to build something, an AI system that will be able to execute tasks, and the task was to to go to the market, fetch data, and return, right? But you know what happened? Just at the first stage of building that robot or building that bot, it's not even, I didn't even use like an agentic approach to building it, right? It was already like the speed, the versatility, the way it thinks, make decisions. So immediately after the first stage and review of the bot, we are like, no, we can't continue this way. We need to actually build restrictions to it. So it's but in those cases, like in this case, they are very, very, very. So I'm just like, okay, imagine this bot now have reinforcement learning capability. So it's not just only say I'm building or I'm just being planning based on a particular task. So the bot was agile. At that point, it was able to take decisions. Like I was seeing the decisions this bot was making, and I was like, wow. So both AI agents has the ability to, let me say, make these decisions on their own. Next thing is, and this is where we are going to wrap up for the theoretical explanation, is reactivity in AI agents, right? Reactivity in AI agents. Reactivity in AI agents. So I'll really say, if you can screenshot, please do well to screenshot and post about this session. Even if you really, really like cover a lot this um in this particular introduction, it's good that you have basic and deep theoretical understanding. So when we are hearing of concept and being able to, let me say, apply or build um capabilities to your model, you know what you are doing. So basically what I'm going to, my key focus area is going to be on React for today's. I won't be the speaker from tomorrow. So my key takeaway from today on this particular session is going to be on React, right? When I mean React, I don't actually mean front-end framework. I mean React. We also have chain of thought, but that is not what we are going to do in this case. So dynamic adaptation to environmental changes. Remember when I said, let's look at it as an AI, as a junior employee, right? In a new, in a new organization. Is currently doing what? Observing his environment, observing his environment, right? So we have dynamic adaptation to environmental changes, real-time sensing, continuous monitor. It continuously monitors environmental states via sensory input. This can be through log files. This can be through monitoring logs. So when you are building an agent, so let me just say this: we have different types of agents. We have different tool agents, right? We have different tool agents. So the first thing is we have an agent that provides text. We also have an agent that provides code as a tool. We also have an agent that calls functions as a tool. So for example, we can provide the log files. Let's say for an agent that is making available code or that is providing code and then executing this code, right? You can provide the log files for this AI agents. So once it once it calls the code tool or a generating tool, right? It's also seeing the feedback, it's also seeing the result of this process, of a step-by-step procedure. Okay, so in this case, we have an agent and it's monitoring its environment through the log file, through the processes, through everything. So in this case, you'll be able to, that is the way of, if we can also implement feedback loop, whereby an external source. I've seen a situation whereby another agent was a judge agent for a particular, let me say, we have another system to come and judge what this system is doing because we are trying to avoid human beings. So in whatever situation, we can see here that we can provide additional work, we can provide, we can monitor and provide feedback back to your agent so that you know, okay, uh, for this particular code I brought about, the log time, the response time is about is really really slow. I have to optimize and refactor my code. These are just examples. So you have stimulus response behavior, quickly react to changes without complex deliberation. That's exactly that bot what that bot was doing. It was able to react to environment and it was when once the the bot went out to the market out there, it was able to act fast, like it was so fast, right? It was taking complex decision and we're just like wow. And if you see the speed this button was working, it was really really amazing. It was really really amazing. So from tomorrow we are going to have in-depth practical sessions. So we have contextual awareness, incorporate simulational understanding into responses. So let me show you something here. um Let me show you integrate feedback. Yes, okay, this is what we are looking at. Integrate feedback. So observability, we have system feedback. We have for system feedback, we have error messages, success notification, and status code. Like I explained earlier, you can pass this into your LLM and to observe this and get it back um as a feedback. We have data changes, database updates, file system modification, state changes. We also have environmental data, sensor reading. Let's say your agent is connected to a hardware. We also have resource usage. We also have response analysis, API responses, query result, computational output, time-based event, and the rest of it. We also have schedule types depending on the particular of the type of observation you want to look at, you want to do. Remember, always have this mindset or understanding that oh, an AI agent is like what? Is like a junior employee which is employed into what? A new company like Google. So how can you do this in code? We have after performing an action, the framework follows these steps in order to. So you can pass the action to identify the functions to call and the argument to use. Can execute an action and you can also append the results as an observation. Okay. So if you have any question, just be prepared to ask your question or you can drop your question in the chat section. I'm going to go through it. Even if you have a contribution, feel free to drop it there in the comment section, in the chat section. So for lastly, before we go into a quick demo or going into the practical part of an AI agent, I'd like to talk about React. I made mention of React, right? I made mention of React. And what does React mean? So if you bear in mind the three things I said, we are going to see shortly. What does React means? React. So basically, so let's use the React approach, okay? So when we're actually talking about React approach, in this session, we dive into inner workings of an AI agent, okay? So RE means ability for it to do what? To reason. ACT means to reason, act, plan, and then act on that plan approach, okay? So this is like the best way of building AI agents. In this session, we will explore how the agent leverages its internal dialogue to analyze information, break down complex problems into manageable steps, and decide what action to take next. Additionally, we will introduce the React approach, a prompt technique that encourages the model to think step by step before acting. Okay, so now the prompt you are passing into your LLM matters a lot. And I'm thinking there is an example here. So if we have example here, I'm going to explain this shortly. The prompt you pass into an LLM matters a lot. I don't know if you can see. Oh, I guess I'll just have to make this. I'll just reset this. Okay, so when we get here, right? So when we are talking about when we're talking about planning, let's say we have a simple something that is a little bit logical, right? Something that is a little bit logical. But if you just pass it directly into an LLM, it will be difficult for an LLM to get it at first. But then, if we have a prompt to say plan, okay, list out tasks, connect to any tools you need, and let's say we provide tools to it, and then follow a set of tasks, we see this that for each of these steps, the LLM will be able to get, the agent will be able to get a particular task right, instead of just going straight to the point or hitting it directly. So we have, for an example, here are some common thoughts. So basically, when you are talking about reasoning, when you are talking about thoughts, is the way you prompt your LLM, is the way you run your AI. Remember, LLM is our AI, is our brain. The way you want your brain to work, that is the AI, the brain of your LLM, the brain of your best LLM to work, is how you want it to work. Okay, so through this process, the agent can break down complex problems into smaller, more manageable steps, reflect on past experiences, and continuously adjust its plans on new information. Okay, here are some examples of thoughts. So we have planning, analysis, decision making, problem solving, memory integration, self-reflection, goal setting, and prioritization. So let's look at planning, for example. I need to break this task into 3 steps. Number 1, gather. Number 2, analyze training. Number 3, generate report. Okay, so this is a kind of planning thought. The kind is we are leveraging on the planning. We are leveraging on um the planning reasoning. Okay, you also have analysis, something like based on the error message, the issue appears to be the database connection parameters. This is very, very practical. I mean, for those who use agents to be able to let me say, go through their to be able to debug or help debug their programs. You can tell here, you can say here for sure that a lot of times we see AI agents, do this a lot, right? You see LLMs tell you things like, okay, based on the error message provided, the issue is that we are not doing a particular thing correctly, or this is happening, or this is wrong with your program. Can you still hear me? Can you still see my video? Can you still see my screen? Okay, okay. So is 1 hour already, and I'm almost wrapping up. We have decision making. Given the user's budget constraints, I should recommend the mid-tier option. We also have problem solving. All these are different approach to building different agents or giving thoughts to your LLM. We have problem solving. To optimize this code, I should first profile it to identify bottlenecks. You also have the user mentioned their preference for Python earlier. So I'll provide examples in the code. Talking about memory integration, we also have self-reflection. My last approach didn't work well. I should try a different strategy. We also have goal setting. To accomplish this task, I need to first establish the acceptance criteria. Okay, so this is the reasoning and using the React approach. For example, okay, it seems this is not really showing correctly. Okay, let me just copy this image and take it to the slide. All right, so you can see a little bit clearly from here. Let me slide show so it will be bigger. Good. So in this case, let's look at view few short prompts. Let's look at few short prompts COT. Let's look at zero prompts, and then let's look at zero short COT. That is, let's think step by step approach, right? You can see here in this case that Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Each has 3 tennis balls. How many tennis balls does he now have? A juggle can juggle 6. Okay, that was the first case example, and it's very simple. That's why no matter the prompts, or let me say, no matter the thought of reasoning we are giving to our agents, it's very easy. You can just jump right in and say, hey, the answer is 11, and you can see it gets it right. But if you look at few short prompts with COT, you can see there that the response is given to Roger started with 15 balls, 2 cans of 3 tennis balls each. And then at this point, all LLMs are all agents are still can still arrive at final answer of 11. But let's look at a more technical example. The juggler can juggle 16 balls. Half of the balls. So let's follow it step by step, right? The juggler can juggle 16 balls. Half of the balls are golf balls, and half of the golf balls are blue. How many blue balls are there, right? So let's follow it step by step. The first step is that there are 16 balls. Half of the balls are golf balls. So 16 divided by 2 is 8. Now half of the balls are blue. That is making it 4. 4 of the balls are now blue. So how many from here? How many blue golf balls are there? And from my explanation or from my calculation, you can see that there are what? There are 4 balls. Okay, but the few short prompt didn't get it right. Okay, but let's look at a more cognitive prompt or reasoning. You can see here that the juggler can juggle. Okay, the juggler can juggle 16 balls. Half of the balls are um golf balls, so they are 16 divided by 2 balls. Half of the balls are blue balls, so they are 8 divided by 2, which makes it what? 4 balls, correct. So what this means is that allowing your agents to reason through the process is much more better than telling, okay, provide answer. Didn't even understand my point. It's much more straightforward to say provide answer, or let me say go straight to the point and then provide just zero shots. I ask you and you provide, you do this and I do that. So in most cases, you need to allow our agent to do what? Think step by step. Okay. You need to allow our agents think step by step. So in this case, what we just exploit here is allowing our agent to have this capability to be able to think or reason step by step. And then lastly, to wrap up, we are also going to look at enabling agents to engage with its environment. So how can we enable agents to engage with its environments? So especially through code, right? So we have the JSON agents, and for most of us here that has practical agents on building practical experience on building AI agents, you can see here that most times JSON agent, that is the action to check the action to take is specified in JSON formats. Okay, we have, like, if you look at open AI function call and a lot of based LLM providers, we are providing a function to your LLM. There is like there is a function called there is JSON, whereby you can provide the name of your function. I mean, this is AI agent suite and your learning doesn't stop here. So please go home and then try as much as possible to experiment with this. And then uh let me see. We also have code agent. The agent writes code block that is interpreted externally. Maybe there's an external body to execute the code, right? So it gets executed and then it just gets what? It gets feedback based on that. Now, this is the most popular. This is the most popular function calling agents. Function calling agents. It is a subcategory of the JSON agents, which has been fine-tuned to generate a new message for each action. So this is an exact example. Let's say we want to add function calling to our AI agent, right? Once you add function calling to our AI agent, it's easier for us to just say, okay, we want to add a tool through function calling. It's easier for us to just say, um, it's easier for us to just pass it through function call and using function tools wrapper around it. So let's say it gets whether, for example, uh, action input, location, and network. So we can provide a tool through function call, and this is another example. I'll just say this is another example. This is another case whereby we are now providing capabilities to our agents. Okay, I'll just take this out and then I'll bring this here. So I'll make this smaller a little bit. All right, cool. So you can see clearly, and I'll just like show. So this is the different approach, right? This is the different approach when it has to do with enabling adding tools or actions, right? Remember we talked about JSON, we talked about code, and we also talked about function code. So let's say we have a particular case to determine the most effective country to purchase the smartphone model. Code Act 1, the countries to consider are the USA, Japan, Germany, and India. So now let's say we have API, we have two available APIs, lookup rates, that is by country, we have convert and tax price, we have floats, we have rates, we have convert tax, that is which takes in the price exchange rate and the tax rate. So we also have the estimate final price function, We also have lookup phone price. We also have estimate shipping cost. So at the end of the day, we want to see the countries to consider. We want to see the country to consider to purchase the smartphone model. Okay, so we are taking in account. Um, we have different functions to be able to look up phone price, estimate final price, act tax, and the rest of them. So let's say we are using an LLM agents using text and JSON as action. Okay. So first, it returns a list of JSON. So now, if you are passing in a function, it can now do what? Return JSON. So this is from this JSON, you now pass this JSON. So you can basically do this. So from this JSON, you can pass the particular function with the parameters, call it directly with that function and parameters, and now get your what? Your structured output. Okay. So that is exactly what is happening here. In this case, it returns a JSON, okay, and then it calls the JSON. In the JSON, it gives you the tool to say, and this tool is the function now, call phone price, and the model code at country Germany, right? So this is going to go much more longer, even if it works, because for each of the price, for each of, you have to be very logical and technical when passing your tool that is for your functions. Okay, but we are looking at code act LLM agents code as action. I should calculate the phone price in USD for each country, then find the most cost effective country. So, but if you're actually using code as an action, it's to be able to write code to call this code, right? To call these functions. So if you are looking at 5 countries, to be able to call the write code to use this function 5 times, and then with fewer steps, you arrive at the same answer. So basically, that is just it about um, being able to add, being able to, let me say, allow our agents to call any tool and then use it. So lastly, what we are going to look at is observe integration feedback loop. So like I said, observations is how an agent perceives the consequences of his action. They provide crucial information that fuels the AI agent thought process. That is the future action. There are signals from environment. So there are different ways you can collect feedback loop, append it to the results, and then pass it back to the agent, pass it back to the best LLM to be able to take observation. So we have explained this already. So far, is there any question, or is there any question that we need to? Is there any question so far on what we have done? Okay, how do I get? So I want to go over again. Okay, how do I get the recordings? Before the end of this session, I'm going to walk you through how to navigate, or how you get the recordings. I'll show you our YouTube channel, our LinkedIn channel, and then the GitHub repository we are going to use to be able to yes, to be able to get the recording. So I'm actually going to, in our machine learning, your YouTube channel, let me provide the link. There'll be a playlist created and shared via the groups. Okay, so you can watch the recording there. There on the GitHub repository, there's going to be starting from tomorrow, but I'll just show you a practical example of the code base we are going to use and how robust it is. So I guess for them, I'll just have to I'll just have to full I'll just have to sidebar, okay, spotlight style, and then I'll just be okay, pass screen. So the recording. So let me stop presenting and present something else. Okay. So let me share my entire screen. Let me share my entire screen. Share and then show you. Okay. So basically, this is what we're supposed to do today. We have a very, very, very vast repository of code we are going to use to be implementing for all use cases. So this is going to be made available. We have AI for journals, we have AI agents for whatever you want to do. So from tomorrow, we start building hands-on experiences. Even most of the topics you are going to do is going to be on the we are not just going to build, but we are going to prototype. Okay, to be able to prototype. Then there's a detailed README here, and the README which will be pushed to the repository. Okay, so actually for today, there's no assignment which will be pushed to the repository. They need to be shared, which is going to be pushed to the repository. You can find all information you need to know. Then for our groups, please make sure you join our groups. This is where we are going to share all the resources, and we are in the WhatsApp group file. And then for GitHub repository, just go to GitHub. I think there's machine learning. Okay, so a repository, an organization has been created for, yes, an organization has been created. So this is where you are going to find the this is where you are going to find the repositories, and feel free to contribute to it. So let's go to repositories and then go to the AI Agents Suite. So this is where you are going to see um, detailed content about our program. So in the absence of any other question, I'll just say thank you everybody for joining. Please do well to share what you have learned in the group. Okay, do well to share what you have learned in the group, and then I'll just have to end the session here. Thank you everybody for joining, and see you tomorrow as we continue part two, or let me say day two of our AI Agents Week. All right. So do you have any question? Let me go through the chat section. Thank you for your present. Is it possible to have the slides? Yes, I'm going to send the slides right away. Let me send the slide. Yes, yes, feel free to ask your question.
Good evening, sir. Thank you so much for the presentation. It was well carried. So please, I joined a bit late, so I didn't really start with every other person. I don't know if the presentation slides can be made available, and perhaps the recordings, links to the recording.
Yes, so I've just got to, let me share the link to the slides. I've just gotten the link to the slides, and I'll just drop it here. So for now, you have the link to the slides. So since it's being recorded, it will be uploaded on YouTube on our playlist, and it will be shared to your emails How many of you got the email notification before we actually started the presentation today? Yes, so please do well so that you get all notifications. Do well to join the mailing list so you get the notifications for whether we have PRs or updates available. You're able to have it at your fingertip. But for the recording, it will be made available and it will be shared via YouTube or playlist. So you have the recording will be there. So I'm going to say thank you so much for our partnering communities, machine learning, Uyo. Okay. I'm going to say thank you so much, Computer Vision Africa. Thank you so much, and Talents AI. Thank you so much, Python, Anambra. These are the partnering communities and organizations and speakers that is actually making this AI agency possible. Okay, so you have a whole lot lined up for you, and then feel free to post about it on your socials. You are free to tag any of the communities. Go ahead and make your post, and yeah. So I think that will be all for now. Right. So thank you very much. Thank you, everybody. See you tomorrow in our next session.